Okay, so hey everyone, welcome to HackGujarat. Another session today today we have Alan with us who would show you how to build a cloud connected AR/VR app in less than 15 minutes. Well, I'll just before we start off, I'll just give a brief introduction about Alan, who is he is the CEO and the founder of echoAR. He has a very vast experience in building 3D content management system and delivery network and everything. He is a big nerd for Java, Unity, Android, and everything. He has served as a graduate researcher at the Computer Graphics and User Interfaces Laboratory of Columbia University. He's also served as a research assistant and teaching assistant in many fields of computer networks and distributed cloud networks. Well, okay, that's for the introduction. And today he'll show you how to create a I would say a cloud connected AR/VR app in less than 15 minutes. And this workshop will show you creating AR/VR with no technical skills and coding knowledge required, and scale existing apps by connecting to the cloud. So stay tuned, and there you go, Alan. I'll just give it to you, pass it to you.
Thanks. Hey, everyone. So great to be here. We're going to record this as well. Thank you so much for being here today. We're going to talk about augmented reality, virtual reality, and how you can build a cloud-connected app in 15 minutes or less. So thank you again for being here, and we're going to start right now. So hopefully you can see my screen. We're echoAR, a cloud platform for augmented and virtual reality, providing developers and creators like yourself with tools and network infrastructure to build and deploy 3D applications. I'm going to start by saying hello. I'm Alon, did my master's in computer science at Columbia University, specializing in AR/VR, and did my undergrad in computer science and electrical engineering, specializing in cloud. So a certified nerd and a big believer in the AR/VR space. Before we start, I want to level set some terms that we're going to use a lot today. So we're going to talk about augmented reality, virtual reality, and I just want to make sure that we're all on the same page of what these terms mean. You've probably heard those, but still, I think it will be beneficial to just level set here. So virtual reality or VR is when everything around you is digital. You're fully immersed in a 3D environment, and you're basically seeing everything in 3D. Everything around you is a CGI construct, computer generated image, and you're fully immersed in a 3D environment. Your vision is occluded by some headset or glasses, and it usually also controls what you can hear. As opposed to augmented reality, in which we have digital assets overlaying the real world. You're looking at the world through some optical see-through, like a headset or some glasses, or a camera see-through, like a phone or a tablet. And basically the real world has extra digital content overlaid on top of that. A really good example to understand this is the amazing movie Space Jam, in which we have Michael Jordan teleported into Looney Town. Everything around him is digital. Basically, everything's a cartoon, and he interacts with the bugs and the other Looney Tunes in a fully cartoon environment. That's a really cool way to understand virtual reality. As opposed to what we have later in the movie, and that's augmented reality. We have the Looney Tunes coming to us, teleporting themselves into our world, playing basketball with us and Bill Murray. So these are really cute ways to understand the difference between augmented and virtual reality. Either we are teleported into Looney Town, or Looney Tune is coming to us. Real world example of that is something that you probably know, things like Pokemon Go, in which we have people running around in the real world, interacting with digital monsters that are not actually there. And in VR, we have Beat Saber, for example. It's a really cool game that people are slashing digital cubes based on the rhythm of the music. Super easy and super cool. Another amazing example of augmented reality that's really, really close to my heart is what I did back in my time at Columbia University. We took CT and MRI scans, converted them into 3D, put them on these smart glasses called HoloLens by Microsoft for the physician to wear, and they would basically be able to see the inside of the patient in real time. It was an amazing experience. I would scrub into surgery, basically give the physician this tool and this amazing use case of augmented reality for them to see the patient's inside in real time, basically giving them a map to navigate through the patient's heart, liver, aorta, stuff like that. It was an amazing use case of augmented reality. But in order to achieve this, I had to do something that I really, really hate, and that's waking up early in the morning. I had to go to the hospital every day at 6 a.m., take those 2D scans, convert them to 3D models, rebuild the application, and deploy 3D smart glasses for the physician to wear. And that process was so frustrating. As a developer, I only wanted to do two things. I wanted to manage 3D assets, and I wanted to deliver them to an AR device. And when talking to other developers building augmented and virtual reality applications for retail and shopping and games and indoor navigation and data visualization, they all said the same thing. There was no easy way to manage and deliver 3D data. But if you think about it, this problem was already solved for 2D. If you want to build a website, you can use something like Heroku as your cloud platform. If you want to build a mobile app, you can use Parse or Firebase to power your app as a backend as a service. So we moved from web to mobile to this new type of content, which is AR, VR, immersive, 3D, call it whatever. And the question has to be asked, who's going to build that cloud platform for this new type of content? And you've guessed it, that's echoAR. So we've built that cloud platform for augmented and virtual reality apps, providing tools, the network infrastructure for companies and developers who want to build 3D applications at scale. And today we're going to see how you can build applications like that really quickly. We're going to do a lot of non-technical stuff in the beginning, and then at the second part of the workshop, we're going to do a live coding workshop with Unity, seeing how you can build an application. If there's any questions, feel free to write them in the chat here in Google Meet, or if you're watching this on YouTube, and the YouTube channel as well. Perfect. So think about it. The same way you don't need to be a web developer to update a blog post, you can drag and drop an image or a video, suddenly that appears on web and mobile. And if I'm in New York and you're in California, we automatically get the best streaming experience if we're watching an episode on Netflix. We translated these concepts into augmented reality, basically providing a way to manage and deliver 3D data and get the best 3D streaming experience. What's interesting here is that this connection between content and location is bidirectional. You as a user, you can't move an image or a video on a website, but you can definitely move a 3D couch across the room, and that needs to be updated on the cloud. So this is basically what we've built, this 3D first content management system and delivery network, and we're basically allowing you as developers to build applications really quickly using that. Go to our website, register for an API key for free, or use the affiliated link if you're here through a hackathon to get free premium access to our console. And now we're going to see how you can use that. Just make sure you register. Once you register, you get this automatic email with an API key, with a project key that will allow you to access the system and build applications really quickly. So let's see how that works. So on the left, you see our console. This is what you get access to after you register. And on the right, you just see my phone. I'm going to start with something super, super simple. I'm going to upload some content to the cloud. So I'm going to click Add to Cloud, and I'm going to throw in some 3D model. Here in our console, we allow you to use so many free 3D models. There's basically a repository of 3D models that you can use. It's the same 3D models that are used for 3D printing. And there's also a search engine that you can search for 3D models for free to use in your project. You can also upload 3D models or videos or images really, really easily. But I'm going to start with something simple. I'm going to take this Empire State Building. As I mentioned, we're a New York-based company, so this is obviously a fan favorite 3D model. I'm going to upload it to our cloud. What happens right now is that we take that 3D model, we build and convert it to works on Android, iOS, Magically, Pollens, you name it. And once that's done, we're going to be able to see it here in the console. And now I'm going to open a sample app right here. You're able to download this sample app here from our downloads menu. But obviously, most developers have their own app, and later we're going to see how you can build that. I'm going to plug in my API key right here. So let's see how that works. It will stream the data from the cloud to the device. So basically, the camera will instantiate. You're able to see my apartment right here. The camera recognizes the floor. And there you go. The Empire State is here in my apartment. Super, super simple. I'm able to walk around it, walk inside. It's literally here with me. But what happens when I want to change this to something else? So instead of rebuilding the application or doing anything technical, I'm going to delete the previous entry, upload something else, and that will update automatically in the app and across all platforms that you're using your content. So let's see how that works. So I'm going to upload some other 3D building. Let's do this one. Same process occurs. We're taking that 3D model, building it so it works on Android, iOS, like all these different platforms. Once that's done, I'm able to open the application. You don't have to go through the App Store. You don't have to do anything technical. You don't have to republish your app. Your app is super small because it doesn't have all these content built into the app. It's just a camera that recognizes the floor, and there you go. Suddenly instead of the Empire State, we have this different building being shown. Super simple. This is an example of mobile AR, so a native mobile app. But as I mentioned, we also support other platforms. So let's see now how they work. If there's any questions, feel free to write them here in the chat, or if you're watching on YouTube, feel free to write them on YouTube. Perfect. So we saw mobile. Let's see web. So we work with a company, for example, in the art space. They didn't want to have people, but to force people to install an app. People would randomly walk into an art gallery and would see AR models flying around them through a website. Let's see how that works. So you can click this button right here. It will generate a QR code that you can scan. If you want, and you have a phone right now, just scan this QR code with me or just follow my screen. Basically, most cameras already have this built-in QR code. So you can just point your Android or iOS camera to the screen, scan this QR code. It'll redirect you to a website. You don't have to install anything. And then once that is done, you'll be able to see the same 3D model here on the website. You can click see in AR. It will instantiate the camera through the browser. Again, you don't have to install anything. And there you go. We're able to see now in the same building we saw earlier, we're able to see on the table right here through a website. So I definitely encourage you to scan this and to see the Empire, this building in your surrounding right now. I'm going to leave the QR code right here opened a little bit for you to scan it. So we saw mobile, we saw web. Another platform that I mentioned that we support is Unity. It's a game engine a lot of developers love to use. So let's see how that works. And again, you can see the power of the cloud. You're able to post once, and suddenly it works on all these platforms, on mobile, on web, now on Unity. Camera recognize the floor. Again, no surprises there. We'll see the building right here. But let's say I want to change it. Let's say I want to do something else right now. So instead of rebuilding the application, let's stream more data in real time. So I'm going to click this button right here, which expands the data panel for this 3D model. And now let's say I want to, do something cool. Let's say I want to make it rotate in real time. So I'm going to add some metadata right here. Let's throw in this metadata, direction equals right. Bam, suddenly it starts rotating in real time. How cool is that? Or let's say I think it's really small. So let's make it bigger. I'm going to add a key called scale equals 2. There you go. Suddenly, automatically in real time, you have that data being streamed into the application specifically to this building and allowing it to change. This is free text that you can use. You can enable or disable any feature remotely. You can add or disable features remotely. Later, we're going to see that how you can code that yourself. But basically, this is a really powerful way for you to stream data specifically for 3D content and control features remotely. Let's make it small again, and let's have it rotate. Perfect. So up until now, we saw all these three technologies, mobile, web, Unity, and they all consisted of one AR technology called surface detection. The camera will recognize a floor, and we overlay that floor with 3D models. The surface could be a table, a chair, a wall, a floor, whatever. Another technology that we support is image recognition. Basically, the camera can recognize an image and overlay data on top of that. So for example, you can have a business card, overlay that with a video of you talking. Or for example, another cool example that people did in the previous hackathon, you would scan QR codes, it will spawn videos on COVID-19, but on the back end, people would actually count how many people scanned it and for social distancing. So a really cool use case for augmented reality for COVID-19. So what you can do is you click this button right here, the QR code generator. Instead of doing see on the floor, click see on an image. Open your camera again and scan this QR code. Again, you can do it with me live. I'm going to do it right here on my phone if you want to just follow the screen. It'll redirect to a website. You don't have to install anything. But now keep your phone oriented on the QR code, and you'll see that the 3D model pops out of the screen, basically matches and is tagged with this QR code. So it's a really, really cool way to match content with an image. This image could be anything you want, specifically now it's a QR code, but you can upload custom image, and they will be the target for this AR content. So super cool use case of augmented reality. Perfect. So now that we've seen how you can match 3D models, let's do the same with videos. I'm going to throw in some videos to show you how to do that. You can just throw in an MP4 file, as easy as that. So let's do that. I'm going to upload that to our cloud. The same process occurs as earlier, but now we're converting the video instead of the 3D model. So let's throw that in. Let's also, let's upload let's upload a video with a custom image instead of a 3D model. Let's do that. So here, instead of doing anywhere, I can do on an image, and I can choose an image file. So let's throw that in. There we go. And now let's see how videos interact with and augmented reality. And again, you can see that you can upload as many like different 3D content that you want to the console. Let's open that QR code scanner, scan it, redirects to a website. Again, you don't have to install anything. And then you'll be able to see a video overlaying this QR code instead of what we had earlier, which was a 3D model. There you go. We have this Big Bug Bunny cartoon, which is really, really cool. Same thing occurs here. If I scan this QR code now, there we go. And then I go to this image. Now the camera will detect the custom image as opposed to the QR code as the marker, and will overlay that with the video. Sometimes it could jitter because my screen, the frequency of the screen is a little different. So like it's not a printed image. So yeah, so you can see the video. Sometimes it just disappears, but there you go. We can see the video next to the image, and the image is used as the marker now. Super simple. Other things that you can do is you can upload content based on location. So if I throw in this box, let's say in New York, you can actually build a generic app that every time you open it in, let's say, New York, it shows you the Empire State Building. But if you open it in San Francisco, it's going to show you the Golden Gate Bridge. Super, super simple. One generic app that streams data based on location. Perfect. If there are any questions, feel free to write them in the chat. And now we're going to continue on how you can use the console to build more and basically use more features. So we saw how you can upload content, which is really useful. We saw how you can upload images, videos, interactive content. Now I'm going to show you how you can share stuff. So like, for example, you can click this button and it will generate this short link for you to share those 3D models with everyone. I'm going to paste it here in the chat on Google Meet so people can use it if they want and play around with it. But basically, this is a way for you to share 3D models and videos like really quickly with people you know and love. Other things that you can do in the platform. So we have obviously changing a theme, dark being the default. We have our downloads menu that allows you to download all our different SDKs if it's for Unity, Java, Swift, Flutter. A lot of example code that we're going to see later for Unity and Flutter and React. And the help menu, we have really amazing resources for all you to use. So we have the documentation. Again, I'm going to share the link in Google Meet. This is a step-by-step guide of everything I did so far. It basically allows you to go through this, recreate everything I just did with really colorful GIFs and explanatory information on how to build an application. So definitely go through this link. We have our GitHub page, which is an amazing resource with all these open source projects for you to build applications with. I'm going to share that link as well. Let's look at some of the examples that we have right here. So let's do face change, let's do living room, let's do COVID, and let's do, what else do we have here? Let's do remote work, and let's do freaking museum. So these are really cool examples of augmented reality you can build. For example, if you want to do a face filter app, you can use that. We have the open source code here. If you want to do like a living room inside a living room, that's a really cool example of how you can like binge watch a movie inside a virtual living room. We have an example of COVID-19 that we're later going to recreate in the coding portion of this workshop. Here we have a remote work example. You can have like this hologram of a person speaking. We have a really cool image-based example that you can have like images coming to life. So definitely check that out. I shared the link here for you to all basically go through these examples and recreate them together. We have some more code examples ready to go. So like if you want to build an application for Flutter or React or Unity, just take this code, plug in your API key, build it, and you're ready to go. Like you don't have to do a lot of coding, specifically for once here from a hackathon. That will be really, really easy for you to get started. Join our support Slack as well, because you can ask our support team questions if you're getting stuck, and I'll hang around in that Slack as well to answer any questions later. Email us, tweet us, super easy to get in touch. So what else can we do? So we saw how you can manage content. Let's see how you can manage data. As we saw earlier, you're able to add metadata to each content entry. We have a global database. So for example, we worked with a company who did this scavenger hunt, kind of murder mystery game. And they had data associated with different models, but also data that is associated with the entire game. So with all scenes, you can add that here. Payment is a really cool page, shows you how much API calls you're making, how much storage and bandwidth you're using. If you're using the affiliated link that we provided with the hackathon organizers, you're going to get this tier for free. So definitely check that out and use that resource. Location is a cool page, shows you the distribution of content. So remember that we added that box in New York. There we go. We can see it here. And we have all these different servers that are supporting your application and the distribution of content that is all around the world. I just added data to my project, so it's pretty empty. Security is a really cool page. If you're a team of developers, make sure to add your team members through this page so they can all access the same project. Insights is a cool page, shows you again how much API calls you're making, how much bandwidth you're using, and how much storage. We just streamed the apartment building, so we see spike in usage. We can see some data on the project and how it's being used. We can monitor the users that are using our application. Tutorials is a really powerful tool for you to see all these different examples, have some frequently asked questions, and get links again to the documentation or GitHub pages right here. Inspiration, my favorite page, has so many examples of projects that people build with echoAR and without it, for art and the mystery game that I mentioned, and some project that we did with Verizon 5G, and things for gaming and shopping and retail and data visualization and military use. In COVID-19, there's a few amazing examples that people built in previous hackathons, like this VR project that shows how long COVID lingers at different surfaces, or that COVID tracker that I mentioned. So many amazing examples here in all these different fields that you should definitely check out. If you build something with echoAR and you submit it, we obviously feature that in the inspiration page as well. This is a really cool project people built recently, like a kind of mask visualizer. So definitely go through this page to get inspired to see what you can build. This is another cool patient data kind of project that people recognize someone's face and then show their patient data. Really, really cool stuff using augmented reality. So definitely check that out. So now we did a lot of non-technical stuff, like we uploaded content, we see how you can spawn an experience in AR, super easy. Now we're going to transition into a more technical part of the workshop in which we're actually going to build an app code on a platform called Unity. So all you have to do after you register is download our Unity SDK right here. It's a file that you can double click, and that will basically integrate into your game engine. This is Unity. It's a game engine a lot of developers love to use for AR, VR. This is an empty scene. Once you integrate our SDK, you can go to echoAR examples and then a sample. Again, it's going to open this empty scene. There's nothing here, just the echoAR game object. And when I plug in my API key, let's see what happens when I press play. So again, this is an empty scene. There's nothing here. But when I press play, automatically things will start to stream from the cloud to the game engine. And there we go. We have this building right here. We have the video playing. We have the fox occluded by the building. Let's change everything a little bit. So I'm going to delete the video because it plays in my ears. You see that I'm deleting the video. Automatically, it deletes from the game engine almost in real time. I can move the fox a little bit so we'll all see it. Let's do x equals 10. See how data is being streamed automatically to the game engine the same way we had earlier streaming it to my mobile phone. When I unplay this scene, everything disappears. So basically, again, nothing persists on memory. Your app is super small when you build it because it just accesses the camera. It doesn't actually have the assets being pre-built with the application. When I press play again, everything will turn to what we had earlier. So we have something that we call a stateful CMS. It remembers the state of the scene and basically recreates it. You see the fox is 10 feet away from the building is rotated. So this is a really simple example of how to automatically stream things for 3D from echoAR. Now let's see how we can change or add some features. So I'm going to delete the building and move the fox back to the center. So we have Arctic Fox right here. What's cool about echoAR is that every 3D model has an associated script attached to it called custom behavior. This is a C# script in Unity format. If you know C# or Java or any other object-oriented language, you're pretty much set. It's really easy to build an application with it, and now we're going to add some feature. So let's go through this sample code. So we have, again, this is a C# script in Unity format. It has two major functions. One is the start function, evident by its name, happens when basically it's called upon when you start the application. And we have the update function, which is a really cool function that happens, check this out, every single frame. Remember, you're coding in 3D. This means that this function happens every single video frame. You have this video rendering, you have this scene being rendered with frames, and this function is being called every single frame. This means that this function needs to be really, really tight, and you should really watch that complexity. If this function hangs or gets stuck, your entire application hangs or gets stuck. So make sure this function is pretty well optimized. But before we go to that function, let's start with the start function, go through how we can add a feature. So in the start function, we have this snippet of code that adds some remote transformation script. This is the script that controls the rotation, the movement. And then we have this short snippet of code that says the following. Do I have any additional data associated with my entry? If I do I have a key called name? If I have a name, let's set that name into to the name of the object. So let's see what that means. If I go back to the console, now it's called Arctic Fox. But if I call this, let's say, let's add some name. So I'm going to do name. Again, this could be anything you want. So let's do name and set a name for a fox. So what's a good name for a fox? Let's call it Kevin. Now when I press play, data will stream from the cloud to the device. And then automatically we see the fox is named Kevin. Super simple. How easy is that, right? We're able to set some inflow using some data that is stored remotely. If I change this name now, let's say from Kevin to some other name, let's say Sam, nothing changes. Why is that? Because that snippet of code to change the name, that feature of name setting, is actually in the start function. It only happens when we start the application. If I'll restart this application, then that code will be initialized, and then we'll see the fox named Sam. So how can we do that will happen every time in every frame? You guessed it, we're going to move this snippet of code from the start function to the update function. So let's put it here. Now, every single frame, we're going to ask, do I have a name? If I do, let's set that name to the name of the object. So let's see how that works. So now we're going to have Sam the fox instantiate. There you go. And now if I want to switch its name, I'm going to click it. I'm going to do back to Kevin. And voila, suddenly it's Kevin again. Super, super simple, right? But now, because this code runs every single frame, we're able to change things remotely in real time. So take advantage of that. This was obviously a really simple example of how you can stream data. But this, again, could be anything you want. You're limited only by your imagination. You can control if flows. You can control features, disable or enable features remotely. Consider the update function as almost like an infinite for loop, like a while true loop that you can use to manage data. And now we're going to see a more complex example of a 3D application that we can build together. Again, if there's any questions, feel free to write them in the chat on the Google Meet. OK, so I'm going to leave the fox and I'm going to transition into a more complicated example. Let's upload some content again. So let's do that together. So I'm going to upload a 3D model from my computer right here. And I'm also going to attach this Excel CSV file, basically a file with all these keys and values preset, because I want echoAR to parse them and upload them automatically, so I don't have to type them manually. So you can upload any CSV with this like pairs of keys and values, and it will automatically parse it with your entry. So like scale, direction, and all these continents I'm going to throw in right now. Uploading to our cloud, the same process that we're already used to, and I'm going to swap the custom behavior script under the hood to basically get new functionality that we're going to review together now. Perfect. So we have Earth right here. If I look at the back panel, I see all these data points right here that we uploaded automatically. And now let's look at the custom behavior script together to see what it does. So suddenly we have this array that has all the continents in. OK, we have the dictionary, some data structure. The start function looks exactly the same. But now the update function is much more interesting. Let's see what it does. So now the update function asks, do I have any additional data? If I do I have an entry called scale? If that exists, let's parse it into a number. And then let's iterate over all continents. Ask, do I have a data point for a continent, a specific continent? If I do, let's parse that number as the number of COVID cases in that continent. Later, we'll see if I have a graph. Let's scale that graph to the size of the number of cases. If I don't have a graph, let's create one. Let's create a cylinder, give it a color, give it a name, give it a position, a scale, add some text to it. And if I don't have a data point, let's just delete the graph altogether. So let's press play and see how that works. Pressing play, again, empty scene, data is being streamed from the cloud to the game engine, and voila. Here's our planet Earth spinning, and we have this 3D graph that is really cool that you can basically show cases of COVID in each continent. If I want to change data in real time, no worries at all. It's already pre-built. If I update Antarctica from 1 to 8, bam, the graph updates. If I delete Antarctica, bam, it disappears. So another really cool example of things that you can build in 3D. You can take this project, as I mentioned, it's open sourced on our GitHub page. You can take that project, you can hook it up to a third-party API, for example, connect this to the WHO, the World Health Organization API, to actually get the numbers of COVID cases, and instead of putting them manually, have them stream in real time and basically expand this project. Super, super simple. And later you can just build this project here and build it for as an Android app, or even like a PlayStation 4 app, or an iOS app, whatever you want. And again, when I unpause it, everything disappears. Super simple. So make sure you register for an API key. Like I mentioned, you're going to get access to our platform automatically, and you're going to be able to build the application that I showed you how to build, and deploy the AR web application as I showed you earlier. So let's recap what we saw so far. So in the first part of the workshop, we had a lot of non-technical things, right? You can just drag and drop 3D models as a content creators, and automatically you have AR experiences. If you're a developer, you can use any client-side application. If it's Android, iOS, Magically, Pollens, you name it. If you are designer, again, you don't have to do anything technical. We built, store, and delivered those assets to headsets, mobile devices, browsers, everywhere. We have a question in the chat. What are the other roles other than AR application developer? There's so many amazing things. You can be a designer, you can be a UI UX 3D designer, you can be a 3D modeler, you can be an interaction designer. There's so many really cool examples of this, specifically in the 3D space. If you think about it, how do you design selection in 3D? Do you point at something? Do you call it out? There's so many really cool and engaging aspects of designing a 3D app that are so non-obvious, and you can basically do that even if you're a non-technical developer. Developers who are using the application obviously save time and money. Content creators can basically interact with the system with no technical skills, and companies get scale data all over the world. Henry's asking what types are allowed for 3D models. So we support OBJ, FBX, GLTF, USDZ, STL as well. But the good thing about echoAR is when you upload one of these file formats, we automatically convert them to all the other ones. So if you upload an OBJ file, we'll automatically convert it to, let's say, USDZ, so it'll work on iOS. I really recommend using the built-in library for 3D models, because you can search literally for everything you want, and that will automatically be assured that everything works in the right format. But great question, Henry. We talked about use cases. We talked about surgery. We talked about interior design, games, shopping, tourism, ads. And we saw the inspiration page that was filled with amazing examples of AR and VR that you can build. And I'm so excited to see what you're all going to build with echoAR. And basically, again, you're limited only by your imagination. You can build so many engaging in examples of AR, VR that are really, really mind-blowing. We have a question, does echoAR support Unreal Engine? So yeah, so we have a RESTful API, again, in our documentation that you can use anywhere you want. We don't have a specific SDK for Unreal Engine, unfortunately, but you can use the RESTful API, basically just doing API queries to echoAR, and that will work in Unreal Engine as well. No worries at all. A little bit about us as a company. We won a bunch of awards. We're back with some of the most amazing investors in the country, like Techstars and Ramad Ventures and Verizon. And we were featured in all these crazy tech events. So when things go back to normal and you're back going to tech events, make sure to find our team, say hello. We're being asked, what is the best language for AR developments? So it really depends on what platform you want to use. So C# is really good if you want to use Unity. JavaScript is really good if you want to use web. Java is really good if you want to use Android. Swift is the best for iOS. But personally, I really like C# and Unity, because specifically in Unity, you can build applications for Android and iOS altogether, like it's cross-platform. And the echoAR Unity SDK is the most robust. So I would definitely recommend Unity and C#. We love to say that we power experience across all platforms. But again, make sure to find the one that you want to build your application with and align it with yours. And check out our inspiration page for all these amazing examples for web and mobile and image recognition and surface detection, the things that you can build. Make sure you register for an API key. Again, use the affiliated link that we provide the hackathon organizers, so you can get that promo for free, or just start using our application through www.echoar.xyz. And join our Slack, tell our team that you came in through a hackathon, and we'll be happy to upgrade you. thank you so much for being in this workshop. Really excited to have you all here. If there's any questions, feel free to ask them now. And if not, again, feel free to reach out through Slack, and I'll be happy to answer any questions later. Stay safe, healthy, and sane. Thank you so much for being in this workshop. And again, I'm super excited to see what you're all going to build with augmented and virtual reality. So thank you so much, everyone. Have a good one.
Yeah, I guess that's it. There are no more questions in the YouTube chat, so I think that's it for today. Thanks, Alan, for organizing this amazing session for us. And I hope everyone uses this echoAR platform in the hackathon too, because there are so many people aligned to AR in the hackathon. So echoAR might help and should help everyone. Yes. Thanks, Alan, for joining us.